quotient rule. Alright? Looking at quotient rule. So from the word quotient has to do with fractions. It has to do with division. Are we together? It has to do with division. When you get the word quotient, you need to understand that it is related to the word division. Quotient of 2 and 5, okay, it's like 2 over 5. Quotient of 1 and 2, 1 over 2. Do you understand? So quotient rule, please go down. The quotient rule of differentiation. The quotient rule of differentiation is utilized in finding the derivative. The quotient rule of differentiation is utilized in finding the derivatives of functions which divide themselves. I'll take it again. The quotient rule of differentiation is utilized for finding the derivatives of functions which divide themselves. So when two functions are dividing themselves, the rule to apply is what? Quotient rule. I told you that for product rule, when two functions are multiplying themselves, that's when you use product rule. When you see this over this, automatically the rule to use is what? Quotient rule. Now, okay, so the quotient rule is giving us follows. The quotient rule is giving us follows. The quotient rule is giving us follows. So now, if y is equal to u over v, now u is the first function, v is the second function. This is the form it takes. Sometimes you see something like this, f of x all over g of x, or something like this. This f of x is one function, g of x is another function. So if y equals to u over v, or f of x all over g of x, dy over dx will be equals to v du over dx minus u dv over dx all over v squared. This is the formula for quotient rule. V dv over dx minus u dv over dx all over v squared. Remember product rule is u dv over dx plus v dv over dx. There is no divided by v squared anyway. Alright, so this particular one is represented like this. Our u still remains our first function. Our v still remains the second function. Don't forget that it will not change. Given that v is appearing first doesn't mean that v will be the first function. No. V is still second, u is the first. Now, look at this v squared. There are some rules that apply to this guy down here. Whenever a function v has multiple entities, don't expand. For instance, if v is 2x plus 3, please, you have 2x plus 3 squared, am I correct? Right? Don't come here and say 2x plus 3, 2x plus 3. Don't expand this guy when there are two entities in your v. The only time you can expand is when you have one entity. For instance, now 2x is one entity. 4x squared is one entity. You can expand. But don't expand. Why shouldn't you expand? You shouldn't expand because it would affect the simplification of the entire derivative. Because the idea is to ensure that you simplify it. But if you want to break this down by expansion, you will be tempted to want to cancel with what you have at the top, and it can affect your answer. So when you have multiple entities as your v, just write your 2x plus 3 squared and leave it like that. You get a final answer. But if you have 2x, alright, you have 2x times 2x will give you 4x squared. If you have 4x squared, for instance, 4x squared times 4x squared will give you 16x raised to the power 4. Alright? So it's only when you have one entity that you should what? Expand. We'll look at an example. Alright? Now take this example. Take down this example. Now, given that y is equals to 2x squared divided by x cubed. 2x squared divided by x cubed. Find dy over dx. Normal algebra, you cancel x squared, x cubed, x squared. X will remain here, right? So you have 2 over x, is it not? That is normal algebra. But it's not normal algebra you're doing here. It's not algebra and trigonometry. You are doing differentiation, which is calculus. So I told you that whenever you see a function y in this form, when you have one function dividing another function, u over v, f of x over g of x, please and please, what you apply here is quotient rule. Does that make sense? Alright, so now let's proceed. So you know how we did it in product rule. You have to first of all arrange. Your u is 2x squared. Your v is x cubed. Like this, then you do your dv over dx and dv over dx. dv over dx is what? 4x, right? 2 times 2, 4. 2 minus 1, 4x. dv over dx is what? 3x what? Squared. That is 3. Remember from power 1. 3 times 4, 3 minus 1, 3x squared. You have arranged it like this. So what you have to do, just substitute it into the formula and you get your answer. So we know that dy over dx equals to v dv over dx minus u dv over dx all over v squared. Right? So we have to just substitute the parameters that we have been able to obtain through this arrangement into the formula. Okay? So it means that dy over dx will now be equal to our v is x, our v comes first. X cubed du over dx, bracket this guy. Du over dx is 4x. X cubed times 4x. Then minus your u is 2x squared. Bracket 2x squared. Times your dv over dx is 3x squared. You say 3x squared. Alright? Then you come here and you divide by v squared. Your v is x cubed. So you say x cubed all squared. Can we expand this entity? Can we expand it? Yes. The reason why we can expand it is because it's only one. It's only one. We cannot expand if we have 2 entities. X cubed is one entity on its own. If we have something like x cubed plus 5, we have 2 entities. If we have, let's say, 2x squared plus 6x minus 3, we have 3 entities. We have something like, say, 3x cubed plus 4x squared minus 9x plus 100. You have 4 entities. Okay? But here, you have just one entity, so you can be able to like expand, okay, the entity. Alright, so now let's proceed. So x cubed times 4x will give us 4x raised to power 4, am I correct? Minus 2x squared times 3x squared, 2 times 3, 6, x squared times x squared, x raised to power 4. These are like terms. Okay? Then divided by x cubed all squared is we saying x cubed times what? X cubed. X cubed times x cubed give us what? X raised to power what? X raised to power what? 6. Or is it 9? How is it 9? 3 times 2. Is that the power? Have you forgotten law of indices? You add the powers. Law of indices, if you're multiplying a, let's say xa times xb is xa plus b, is it not? If we have xa over xb, it is xa minus b, right? So it is x 3 plus 3, not 3 times 3. So x raised to power 6. Are we together? So now this will be 4x cubed minus 6x, 4x raised to power 4 minus 6x raised to power 4 will give us minus what? 2x raised to power what? 4, right? Divided by x raised to power 6. We can still reduce it, right? We can still reduce it now, is it not? X raised to power 6 here, 2 remain here, right? Is it not? Yes, so we now have minus 2 over x raised to power 2. This is our final answer, dy over dx. Now, if you have 2 entities here, it can be very complicated to do your cancelling and all of that. That's why we say you only expand when you have one entity. Don't expand when you have 2 entities. So this is our dy over dx. So this is the general understanding of quotient rule. Just understand that when you have two functions dividing themselves, that is when you apply quotient rule. Know the formula. dy over dx is equals to v du over dx minus u dv over dx divided by v squared. Don't mix it up with product rule. Product rule is dy over dx equals to u dv over dx plus v du over dx. Alright? So that is it. So quickly you will try this. So let's say given that y is equals to 4x plus 9 divided by 2x divided by 2x plus 3. 4x plus 9 divided by 2x plus 3. Find dy all over dx. So differentiate this. Alright?